So, good morning from down under, and thank you very much to the organisers for asking me to speak about making evidence-based research possible, easier and the norms, and what funders and researchers and others can do about this. And I'm going to begin by talking about the nature of the problem briefly, and then talk about the types of things that have been done and what else we might do to try and work on this problem. So a bit of history first of all. We could go back a long way, but I'll just take this article of Doug Altman's The Scandal of Poor Medical Research in 1994 as a starting point, where he said huge sums of money are spent annually on research that is seriously flawed through the use of inappropriate designs, unrepresentative samples, small samples, incorrect methods of analysis and faulty interpretation. And it had long been a frustration with Doug that these sorts of problems arose in research, particularly simple fixes that could be done that would salvage the huge waste that occurred in a whole project being done and then, for example, a faulty analysis or incorrect reporting. In 1994, though, he didn't document how big those huge sums were, and Ian Chalmers and myself in 2009 tried to estimate this in an article we wrote in The Lancet of about 85% of research being avoidably wasted. Of course, there's inevitable dead ends, etc. in any research that we do, but this was the avoidable waste in research. And that includes several stages, including what the Evidence-Based Research Network is particularly interested in, which is at that design stage of research. The sorts of problems that we documented in 2009 have been documented in preclinical work as well. For example, Begley and Ellis tried to reproduce the findings of 53 top-tiered papers in Science, Cell and Nature, and could only reproduce the results in 6 of those. And that was done for commercial reasons because Glenn Begley was working at Amgen and wanted to make sure that before they pursued a line of research that the research was at least reproducible. And then in 2014 we had the 5-part Lancet series on adding value and avoiding waste. And followed that up with the conference, the Reward Equator Conference in Edinburgh, where Doug Altman had noted in his keynote about the slow progress in improving waste. He said, "It is my pleasure to be here and to make you feel quite sad about how bad things are, and then my colleagues will, I hope, come forward with great ideas about how we can make things better." So I'm going to pursue that theme of Doug Altman's of talking a little bit about making you sad first of all, but also hopefully end with some ideas that may make things better and how they are actually moving forward. So you obviously know that evidence-based research is defined as the use of prior research in a systematic and transparent way to inform a new study so that it is answering questions that matter in a valid, efficient and accessible manner. And that was, of course, documented, that problems were documented in the 2014 Lancet series, and we'd mentioned them in the 2009 paper. So I was just having a look at what rates of use of systematic reviews to justify new trials we find in the literature at the moment. And this is 4 different estimates ranging from 20% to 54% being justified. They all use slightly different methods, so I wouldn't read anything into the timeline here. Just take these as 4 separate estimates of the range across these different areas of anesthesiology, ophthalmology, major general medical journals and orthopedic trials. But it's not always clear whether the systematic review is being used to justify the new trial or being used to cite for other purposes. But it gives us a sense that things are not well, at least the glass is less than half full probably. So that means that for the consort statement where it says reference to a systematic review of previous similar trials should be given in order to justify and also build on the methods, and I'll come back to the methods, that we're not doing particularly well in that regard. And I'm going to talk about the implications of that in one specific example, and this is for calcium channel blockers in acute stroke, where in 2001 the Venus trial published finding no effects of nimodipine, which is one calcium channel blocker. And they also did a Cochrane systematic review published in the same year of all of the trials they could find of calcium channel blockers for acute stroke, and again found no effect. That's the forest plot on the left here, and you can see the diamond of the overall effect is actually slightly on the placebo being better side. So that made them ask, well, was this based on good animal research? Why were all these 28 trials done in so many participants? And going back to the animal studies, they found 20, and amongst those they didn't show convincing evidence to substantiate the decision to perform trials with nimodipine in large numbers of patients. So this is all the wrong way round. We should have been accumulating the evidence in the animal studies, and then doing the first studies in man and accumulating the evidence in systematic reviews, and that's where evidence-based research should be moving to. And this was work done by Janneke Horn, who published all three of these articles, the trial and the two reviews. And so it all suggests a lot of avoidably wasted research effort with no progress in care as a result of this. So what can we do about this? Well, we could put up a sign in every laboratory that said, "Thank you for not doing research that has already been done." That would be very important. We might also put next to it a sign that says, "The clinical librarian is in this direction. Please go and consult them before you do your new research." But we should also think about what the infrastructure and tools might be that might help those researchers in those laboratories do that in the first place, because people don't do it because of the effort involved in it in the first place. So I want to go back to another example of the rate at which methodological innovations are taken up, and just look at the 40 years that it took for the IMRAD, the Introduction, Methods, Results and Discussion Structure in Journals, to be taken up. This was first mooted in the 1930s, and by 1980 you can see that at least for these four big medical journals it had been completely implemented. This is an interesting 50-year survey published in the Journal of the British Library Association a few years ago. So there's this long gap between an innovation in what we should be doing to better structure reports and it actually being implemented. So how might we do something about it? One way is to think of this as a diffusion of innovations. So Everett Rogers in agricultural research actually looked at this in the 1950s. He was interested in the uptake of hybrid corn. And he classified people as being the innovators, the early adopters, early majority, late majority, and the laggards. And that you may need to do different things for these different groups. Approach them in different ways. And Brian Nosek has laid this out very nicely in a figure that he's got on the Open Science Framework, where he talks about these stages of changing a research culture. First of all, making it possible, then making it easy, making it normative, making it rewarding, and making it required, which sort of correspond to these groups that Everett Rogers had described. For the innovators, you just need to make it possible. For the early adopters, you make it easy. For the early majority, make it normative. Late majority, make it rewarding. And the laggards, make it required or mandatory. So the question is, how might we speed these things up? And we need to think then about how we can make all the things in this pyramid go forward, make it possible, make it easy, make it normative, etc. In order to speed up and compress that 40-year or so timeline. So in a way, that's already been done. I want to take you back to 1836 when the first National Library of Medicine in the US was set up. And just to collect things together in one place that made it even feasible. You'd have to do a lot of work, but you could possibly have done a systematic review then. But imagine with the amount of literature trying to do that on Index Medicus in the late 1950s or 1960s and having to go by hand through these volumes. Well, that's what led to the development of Medlars, Medline and PubMed, was just to make this easier. So we've been doing this for searching. We've actually made it possible and then made it easier. And now it's becoming normative as well, but only because those things existed in the first place. You couldn't mandate that people would always do a systematic review if we still only had Index Medicus. So what I want to do is take that idea of we've done this for some components of searching by making it feasible and easier, but expand that to the whole idea of doing a systematic review. So this was the principle behind the international collaboration of the automation of systematic reviews, that we wanted to make it easier for doing reviews of new research of previous research before you do new research, or just to answer clinical questions. There's lots of purposes for doing a systematic review. And that has had yearly meetings, and I'll thank Hans Lund for hosting the 2019 meeting in Bergen, but we've had multiple meetings of that group and making gradual progress with these. Important was to set out the so-called Vienna principles from the very first meeting, which said that a systematic review production involved multiple tasks, first of all, and we have to think about all of the tasks, not just the title and abstract screening or data extraction, and that automation may assist with all of those tasks, and that each of them can be continuously improved. So we make one step forward, but we need to go better and better and better, particularly focusing on things that are the bottlenecks. But once you solve one bottleneck, you actually move on to a new bottleneck, and you always want to be working to improve whatever the current bottleneck is. And that with all of this process, that we need to adhere to high standards. We're not talking about the rapid review process or shortcut reviews, but doing a full high quality review, but using automated tools to do it in a much shorter time. So we'd been working with multiple groups around the world on this for about 5 years, when we decided in 2019 to try and do our first 2-week systematic review. And we published about this in the Journal of Clinical Epidemiology on describing the processes of it. And I first of all need to emphasize that there are actually two components. One is the automation tools that you see on the right, and I'll talk a little bit more about the components of those. But the second is a change in the process. We couldn't have changed the process without having the automation tools, but equally important to the compressing it to 2 weeks was having this streamlined process that included, for example, a team of 4 to 5 experienced multidisciplinary group of the appropriate clinicians, librarians and epidemiologists, scheduling this protected time in the 2 weeks. You don't need all the time off, by the way, but for some people they'll have to have the majority of time off. Having brief daily meetings where we ask these 3 agile questions. What have you done? What problems have you had? And what are you going to do today? And a big saving in all of this process and compressing it into this shorter period is the mental reload time that you have when you keep coming back to that review problem. You keep seeing the same paper, but you almost need to reread it every time. Well, if you compress it into this much shorter time frame, it reduces that mental reload. So you need both the tools and the process. And this is a list of some of the tools that we used particularly for the that first 2-week systematic review. And I want to emphasize some of these tools we've been developing, but many of them have come from other people as well. For example, our search refiner was developed by the University of Queensland and a group at CSIRO here. And we have to thank Ian Marshall and Byron Wallace for both Robot Search and Robot Reviewer, and to Clive Adams for RevMan Replicant, which helps you write the results section of a review by taking what's in the forest plot, etc., and then generating text from that. It was a brilliant idea of Clive Adams's from the schizophrenia group. And we're extending this range of tools and also trying to improve each one of these tools as well. So just to say where we've gone from here, that first 2-week systematic review, as I said, took 4 people. We had about 1,300 studies to look at and ended up including 8, and it took 8.5 work days. But since then, we've conducted over 20. This is a range of the first 10 of them we'd done, which vary in size in the number of titles and abstracts screened from just under 500 to over 5,000. Number of included studies has varied from 5 to 81. It's been a range of types, mostly randomized trials, but some observational studies as well. And the number of people has ranged from 4 to 14, and the number of work days from 5 to 18. And so you can see the one with a large number of people and the large number of included studies was the one that took 18 calendar working days. By the way, some of these are done over a longer period where you're only focusing on this a day a week, but actually we find it's better to try and compress it into a fairly short period, not necessarily 2 calendar weeks, but a fairly, maybe doing it all within a month. So just wanted to mention one new tool just because I find this one so much fun to use. This is our latest tool, which is the Methods Wizard for writing systematic review protocols. And with this, you answer a series of short answer questions, filling in just the word or phrases that you need, like the population, the interventions, comparators, etc. There's a drop-down menu for what databases you're going to search. It knows the people, so you can say allocate people to various tasks, etc. Everything is short answer. So we use this in a meeting that usually takes somewhere between 1 and 2 hours to develop the protocol, but we're focused on answering the questions, not on writing sentences. And that makes it much more focused and much more fun to do. And then at the end, we press the button and it generates the text that you see in that bottom right hand corner, because it's using canned text, or actually several variants of that, because it randomly chooses from the structures to generate this draft protocol. And I emphasize draft because it's just a start, but it's great to walk out of that first meeting with a draft protocol already written for you without having to worry about the crafting of any sentences, and it's Prisma compliant because of the way that we've structured the Methods Wizard tool. So what more is needed? There's been a lot of progress, obviously, to get where we are, but there's still huge amounts of work that we still need to do. For example, we need to reduce the learning curve for the current tool set that we have. Each of these takes a little while to learn how to use and how they work together. So we have to train people before they come to it, whereas no one has to be trained how to use Amazons, for example. So we need an easier interface. We need to integrate that project management component better, because that's a separate, at the moment, it's a sort of separate guiding set of tools and principles that we use for that, but it could be integrated in with a set of tools. We need to increase the range of the tools and other types of review that we could do, network meta-analysis, scoping reviews, etc. And of course, the world of the literature is changing. We need better linkage to study registries, preprint monitoring and extraction, etc. of tools, particularly as we move towards living reviews that can monitor all of these things, not just PubMed, but also all of the registries and preprints, etc. for things that are coming out. We also need a wider use of the tools, and we'd think of doing that. We've done this with some pilot sites, but we'd like to increase the number of pilot sites and education to do this so that it gradually does become the norm in more institutions. However, to do all of this and to continue this development is also going to require funder support and development and a requirement by funders that you have to have systematic reviews done to justify new systematic reviews. So I've been talking about it for justifying, but I just wanted to also mention, just to close, is that systematic reviews could also help to improve the methods used as well. So, for example, it depresses me to look at risk of bias plots like this where they're in calendar order, and what you see is they should all be moving towards greener, and that's not necessarily true. Why isn't it that later trials should have built on what had been used in terms of methods of the earlier trials? And if you did a systematic review that wasn't just looking at it for justification, but also looking to borrow and build on the methods from previous trials, we should have an improvement and greater degrees of green over time. And an interesting survey of methodologists from European institutions, some 76 statisticians, methodologists, etc., found, again, the cup is half full here. for asking questions about whether they'd use systematic reviews in trial design. The median was 0.44, from 0 never to 1 always, so that half full thing. 67% had used a meta-analysis to determine some other parameters in the sample size calculation, such as standard deviations and baseline risks. 58% considered meta-analysis in effect size or alternative effect size in the power calculations. Only 51% had used meta-analyses to determine the health outcomes. Looking at the range of health outcomes that had been used in previous trials for that question would seem to be an important thing that you could do to try and improve on the outcome measures that had been used previously. So again, glass half full, but another purpose in doing the systematic review that we need to do a better job of, not just the diamond at the bottom of the forest plot, but also looking at the risk of bias and the methods tables that we've extracted to see what we can borrow from those previous studies to build on them. So coming back to finish on Brian Nosek's changing a research culture diagram, I've been mostly talking about some of the infrastructure that's required, but also how to make it easier as well. But we'll also need different folk to help with making it normative, making it rewarding, and finally the funders and institutions may want to make it required, but we need to do all of these other things first before we can move to that mandatory level. And of course we have that infrastructure with the databases and systematic review methods, but we need to develop an understanding of the problems with the meta-research, but also doing the development work on the automation tools and automation processes more generally to make it easier for people and to make it eventually become normative, rewarding and required. Thank you very much for your attention.